please subscribe to my YouTube channel. This is Blessing K, and today we are doing networking for A-level examinations, A-level, Zimbabwe, and other examination boards. So today we will be doing IP addressing is our point of focus, right? So IP means Internet Protocol. So we'll start by defining the term protocol. So protocol refers to a set of rules that governs how data is transmitted in a network, right? So a protocol has to do with how to interpret signals in a network, right? Then how to identify oneself and others or other devices within the network. Also how to start and end network communications. So here are some examples of protocols. We have HTTP, for instance. Then we have file transfer protocol, which is FTP. Then we have VoIP, P, more like that. So these are the three main examples of protocols which we are going to focus on. Alright, when I say HTTP, it's Hypertext Transfer Protocol, which it identifies the request and transfers of multimedia web pages between clients and servers, so in the internet. Then we file transfer protocol. It is to do with the transfer of data between computers, the likes of downloading softwares. Then we VoIP. On file transfer protocol, remember that there is no security since data cannot be encrypted. Then we have VoIP, which is the voice over internet protocol. So it is to do with having internet calls, like on the Skype. I think you are familiar with the Skype. You should take that as an example. Then this is to make what ordinary internet calls. In this segment, we will be doing the format of IP addresses. The format of IP addresses. Before we can continue with this, I advise you, if you have not yet seen my video, you have to watch an episode that is maybe using the link in the comment section, where I explained the OSI model and TCP. So you should be familiar with OSI and TCP, which can be called the IP address models. So now, what is IP addressing? So IP addressing is a hardware independent convention principle to allow devices identified within the network. So when I say an IP address is just let me say it's a way of identifying those devices within the network without considering the hardware type, whether it's a mobile phone or a computer. Each and every device on the internet is identified using these IP addresses. Then the TCP, which I said you should be familiar with, the transmission control protocol, transfers data based on these IP addresses for specific of particular destinations. So when it has been transferred on the internet to certain destinations, the destinations or the receivers are identified using these IP addresses. The format of IP addressing. So as we have alluded, an IP address is represented by four digits which are separated by periods. Probably, let us use this as an example, 102.168.1.1.10, where each digit is in the range 0 and up to 255. It cannot be a number greater than 255. And so these digits are used in different ways to identify a network and the host within the network. So when I say the host within the network, first of all, the network ID, we have the network ID. The network ID, it has to do with identifying the network, because we have a lot of networks within the net, right? Then we have the host ID in the format host ID, which identifies the device within the network. Right. Then we've all understood what is how the format works. Now we have to explain the subnet mask, which determines which part of the IP address is the network ID and which part is the host ID. So the subnet mask is to determine that, and it's also in the format of decimal dotted separated digits like this one, where we can convert them into binary like this, and we can identify that wherever we have zeros like this, it represents a host ID, and when we have ones like this, it represents a network ID. So for example, we have an IP address like 192.168.1.10, right? Then we want to determine which part is the network ID and which part is the host ID. So we should have its own subnet mask provided like this. Then we convert it to binary like that. Then we have a 0 here. So wherever we have a 0, we go to the part related to it and say that this is the host ID. If we also had a 0 here, not having 255, it means that this first part is the network ID and the last part will be the host ID. So when we have the zeros to the subnet mask, then we go to the digit on the IP address, then that digit which is related to the part having zeros represents the host ID. That's how subnet mask works. And then we have a process that we call subnetting. Subnetting, it divides large networks into subnetworks. Networks by what? By borrowing some bits from the host ID to create more network IDs, as you can see. So here are the classes, the classification of these IP addresses. So they are originally divided into 5 classes as shown on this table. So as we can see, we have class A, B, C, D, and E. So the difference within these classes is the subnet masking, the amount of bits taken by the network address, and the amount of bits taken by the host ID, right? So as we can see on the subnet mask, we have the increased number of 255. So the increased number is as the networks, right? As the networks increases, the number of hosts decreases, or the amount of hosts decreases, right? Here on class A, we have the subnet mask 255, then 000, which means we have this refers to large networks for big organizations. For instance, like it ranges from 0000 up to 127, then 255, and 255. This is for 16 million hosts, which means we have a lot of what? A lot of hosts, right? As you can see, the host is greater than the network ID, which means it's large networks. If we have a lot of hosts, it means it's a large network, right? Then we go to number B, to class B, right, which is 255.255.0.0 as the subnet mask. Then the networks ranges from 128.0.0.0 up to 191.255.255.255 for medium networks, for example in universities, where we have about 65,000 hosts, right? Then we have class C, which is this subnet mask, and is the networks ranging from 192.0.0.0 to 223.255.255 for small networks, like in small business, where we have a small number of hosts. So the host is decreasing because the host ID remains only 10. As we evaluated earlier on, we said wherever we have 0 as the bits on the subnet mask, that's the host ID part. Then those occupied by ones, was when we convert this 255 to binary, we have 111, the 8 ones. So when we have the ones like this, it means this is the network, right? The network ID. Then we have class G, which is the overcast of 255, 255, which is the networks ranging from 224.0.0.0 to 239, 255 for multicast networks, which sends data to multiple devices. It means no host is assigned. As you can see, we have the number of hosts decreasing, and now we have no host assigned because it's sending data to multiple devices. Then with E, subnet mask is not applicable, but you can just say 255, 255. Then the range of networks are from 240.0.0.0 to 255, 255. And these are for experiments and reserved, not for public, right? That's it with the classes. As you can see, the number of unassigned IP addresses is running out. So this system of classes A, B, C, and the likes is being overtaken, is being replaced by the IPv6 format, because this was IPv4 where we have 1, 2, 3, 4 bits, and it's being replaced by the IPv6 format, where the number of bits has been increased from 32 bits to 128. Now we've all understood the concept of IP addressing, and we have to look at the difference between private and public IP addressing. So when I say, let us use these features, 5 features, to differentiate the two. So we have usage, range, accessibility, the network address translation, then uniqueness. So for a public is provided by the internet service provider, while this is provided by NAT, which is the network address translation generally. So on the usage, the public IP address is used to identify a component or a network within the global network, which means it identifies each component at global level, right? And the private IP address, the private only identifies a network reserved behind the network address translation, which is probably a vector. And range, for public address, let me set by reference the private, the specific range, like what you do with Wi-Fi, right? Then the public, all other IP addresses not in private IP, right? Then we have accessibility, public, right? Public, it means it can be accessed globally or accessed from the internet. Accessed, let me say globally, to be precise and short, then cannot be accessed directly from the internet, and therefore requires a router. So when I say a router, it's something which provides private IP addresses for these networks. So it provides private IP addresses for devices within the network, right? So a router is the network address translator. So for public, no network address translation is required, and here we need a router to provide IP addresses for devices within the network, the limited network, right? Then we have uniqueness. So public IP addresses, they are unique on the internet, right? Can be to global level. Then these private IP addresses, they are only unique for a specific network. Let me explain this part. Let me say we have a specific organization or building where you have a Wi-Fi or something like that. Each device is identified by a private IP address, which can be the same or similar to an IP address for other devices in another private network. So it is not unique globally. It is only unique within a specific network organization or something like that. Then when we have to do with public IP addresses, they are unique throughout the internet, right?